Never stop believing in hope because miracles happen every day. Good afternoon to all. On behalf of Atal, MEPCO management and personal behalf, it is our great pleasure in welcoming the honorable session speaker, Dr. Devi Mahalakshmi, professor in MEPCO Sherlock Engineering College, Tamil Nadu. Before this session, she served as a different destination at the different premier institutions. Madam has published over 118 research papers in international and national journals and conferences. She was invited a keynote speaker in more than 17 international conferences across India so far. Professor has had very extensive conferences, particularly in AICTE sponsor, FTP, STTP, and a technical workshop that remarkably speaking was. With this brief introduction, we would like to hand over the session to Dr. Devi Mahalakshmi. Let's welcome Madam.
Thank you, Ma. Thank you for your introduction. Dear professors, good morning to you all. Am I audible?
Yes, madam. Please.
Yes, sir.
Yeah. Please audible and visible. Everything is clear.
First of all, I express my gratitude to our college management, principal, Dr. S. Arivalagan sir, convener, Dr. K. Muniswaran, senior professor and head, Department of CSE, and the coordinator, Mr. R. Jabastian, librarian, MEPCO Slunk Engineering College, for giving me this wonderful opportunity. I'm happy to take part in this Atal sponsored 1 week FTP on Management Information System. Thank you, sir. I thank the convener and the coordinator for giving me this opportunity. Thank you, sir. Shall we start the session now? Sebastian, sir.
Yes, madam.
Shall we start the session?
Yeah. You can proceed,
okay.
madam. No problem.
The presentation is it visible to you, participants?
Yes,
Dear participants? Yes.
Yeah.
So the topic I am going to cover today is a recommender system for information retrieval, right? So normally in our day-to-day life, we have a lot of questions and lot of decisions to be taken, right? So which digital camera should I buy, or which mobile phone I can buy, or the best place to visit during summer vacation, or else the best universities, best institutions, or which movie should I rent, right? Or which website I have to refer regarding one particular topic or one particular domain, etc. So our recommender system will provide answer for all such questions, and it will make the users or the customers to take the best decision efficiently, right? So today for this session, the agenda it covers introduction and purpose of using recommender system and the different paradigms of recommender system. It talks about the technique being used, then other recommender systems, recently evolved recommender system, then some of the research topics which can be exploited further, right? So first we need to know what is information retrieval system. So around thousands of years we are following this retrieval system, information retrieval system. In older days, in earlier days, people will retrieve information using some voice messages, that is one-to-one communication, right? So in earlier stage itself, the recommendation, that is information retrieval system starts, because we communicate with our neighbors and we communicate with others and we try to retrieve the information what all required for us or the information relevant to our purpose. So that is where the information retrieval system starts. So the information retrieval system will obtain information relevant to the user's need. Then what is information filtering system? The information filtering system, it will collect the information based on the user profile, based on the user interest and all, it will collect the information and present them. The that is top ranked items or top ranked products will be recommended to the user. And sometimes the user may not know, in the information filtering system, the user may not know the existence of that particular products or that item, etc. Right? Now, both information retrieval and information filtering fields, they cope with enormous amount of information. So the information or the data may be the user given feedback, or else the search patterns, or else it is something like the click patterns in one particular session. And all those informations are processed both in information and retrieval and filtering, right? And it provide relevant information to the users. That is our main objective. So instead of populating all unnecessary or all informations, it is going to search, or it is going to select only those relevant information to the user. It provide relevant information. That is the main aspect. Then it offer personalization, even for a single individual, even for each and every customer. It is going to provide recommendation, or it is going to provide information based on his requirement or his profile, right? So normally information retrieval is finding materials. Usually it is text. We are going to access unstructured data. Usually it will be in the text format that will satisfy the need of the particular user or a group of users, and it will be selected from large collection of information. Normally that information is already stored informations, right? So actually it is going to use the static data, and it focuses on indexing and retrieval of textual informations. And the main concern here is it will retrieve relevant documents. And second concern is it is going to retrieve a lot of informations or documents efficiently. So it is aiming for fast retrieval. So no one is going to wait in front of the machine for the information to be populated. Okay. So it is, first concern is relevant documents based on the user given query. And the second concern is fast retrieval of the relevant document. So the information retrieval system we all know, right? The IR system will receive the query from the user. So the user, based on his need, he is going to put the query, and it will be processed by the search engine IR system, and it will retrieve the information, maybe the documents or text information or images, etc., from this collection, and the list of those items retrieved will be listed to the user. Again, in the listing also, they will follow some ranking. So the most relevant item, then followed by the less relevant item. Like that, it is going to provide the list of items. So one example is our Google search engine. So in the information retrieval system, the main objective is it is going to retrieve documents relevant to the user's information need. So the user is going to provide something like a query. Usually we type some keywords in the Google search. Like that, the user will specify the query, and the system used is search engines. And what is the input for this search engine is the user given query. That is the input which is explicitly given, right? Say for example, in Google search engine, suppose I am typing the query, I am typing a text, COVID-19 prevention. Then you will get lot of informations, relevant informations related to whatever the query you are typing, right? Is it visible to you? Can you see this?
Yes,
So
yes,
in
yes,
the
yes.
listing itself, it will show all the informations based on the ranking. So most relevant item first and so on, right? But here one of the disadvantages, you will get lot and lot of information when we are using information retrieval system as it is. So the user may get confused which site to be followed or which document to be used, right? So actually it is a, even if you are using search engine, it is a time consuming job, right? To pick the appropriate or the opt information. So now we are comparing information retrieval system with the information filtering system. So in information retrieval system, the output will be what we have seen now. Some pseudo relevance feedback. Somehow it is relevant information only. It may not be the opt one. It may not be the data what you are searching for, what you are looking for. So it provides pseudo relevance feedback. But information filtering, it will, the objective is select the relevant items based on the user interest, based on the user interest, based on the past history or profile of the user. The information will be retrieved from information stream. It may be some static data, may not be a static information. So it consider all the information. Suppose today I am searching for, that is today by 10 o'clock I am searching for one product. Then afterwards, once again, I am going to that particular site, means immediately you will get the items related to that item what I am searching, right? So it is using, it is extracting relevant items from the information stream. Even the real-time data is incorporated in this. The systems being used are spam filters and the recommender system. Here the input for this system is implicit data. So the we follow one particular route. We select one item, then we see the items, then we move to another web page and so on. So the recommender system is going to provide some, apart from your normal travel through the website, it is going to provide some additional thing so that the user travel through the website may be changed after seeing the recommended list of items. It may be changed. So some users, they may think it is some interruptions, or they will get irritated and so on. So the main objective of the recommender system is to provide meaningful recommendation for the particular users based on their interest. So it is useful alternative for the search engines or search algorithms. Sometimes it will help the users to discover items they might not have found otherwise. So while searching for some items, by chance you will get some recommendation, and the user or the customer may not know that particular item. So the recommender system, sometimes it will recommend the items, it will help the users to discover new items. Then applications where it is being used. So it is used in almost all commercial online applications. Then in earlier days, it is being introduced to generate the playlist for video or music services only, and product recommenders for online stores, and content recommendation for social media platforms. That is, suppose you are searching for some literature or some journal paper. Once you type the topic, it will show some relevant topics. It will give some relevant other relevant journal papers or magazines, which will be useful to you, right? And used to explore research articles, experts, or financial collaborators, etc. So these are all the applications where the recommender system is being used. Participants, is it okay for you? Shall we move to the next slide?
Yeah, madam. Please move it is full screen.
Yes, ma'am.
Okay. If you have any queries, you can interrupt me. Okay. So now the recommendation system will match the users with items if you take it in commercial websites. So it will make the fast retrieval of information. That is the main objective, and this information overload. So if you use ordinary search engine, it will give a lot of information, extra information, but the recommender system will list only the top n recommended items, top n relevant items to the customer or users. So it is used in sales as guidance or advisory, etc. So it is a software agent. RS is a software agent. It is continuously extracting the information from the users. And the purpose of recommender system, already we know. In retrieval perspective, it will reduce the search cost. So the searching time and all will be reduced, and user will get correct proposals. Through the recommender system, we will get the opt proposal, and user know in advance what they want. So they can easily pick the correct proposal. Then in recommendation perspective, you may have a long tail of information or long tail of items. So the recommender system guide the customers to take decision or to identify the item from the long tail. Then sometimes the user may not know the existence of that particular item. So through the recommendation system, the user will come to know some new item which will be interested to him. And in prediction perspective, it will predict in what degree users like a particular item, right? So based on the ranking. And in interaction perspective, it will give good feeling. Suppose we are using the search engine through the machine, so it will give some responses or it will give some feedbacks. So it gives good feeling for the users. That is, somebody is guiding behind this system, and it will educate the users about the product. Suppose the customer is new to that particular product or new to that particular domain, then the recommender system will educate him regarding that particular product, and it will convince or persuade the user with by giving explanation why he has to buy that product and all. Right? Then in commercial perspective, it will increase the hit ratio, click through ratio and all. So it will increase the profit and optimize the sales margin. So almost in all online websites, online commercial websites, they are following the recommender system. So it reduces the information retrieval time, and the information overload is also reduced. So the recommender component will estimate the relevance based on the need or user profile. It will estimate the relevance, and only those things will be given as recommendation list. So it is the scenario of recommender system. And if you see this RS as a function, the input will be the information, lot and lot of informations in almost in all format, textual information or web link, click operations, or the moving pattern from one link to another link or one page to another page. So almost all kind of informations will be represented, and the user models will be represented, which is the input or the function being followed. And using this model, it will evaluate those informations or the data, it will process those data. Then the relevance score or something like rank will be provided, and based on the ranking, it will list the top n items. So the outcome of this function will be the relevance score or the ranking of items. And different system designs or paradigms are available in recommender system. First one, based on the availability of exploitable data. Sometimes in some situation, we may not get the user profile or we may not get the user interest, etc. So at that time, one particular recommender system will be followed. Sometimes we will have lot and lot of user profile, rich user profile, or other user peer users information, feedbacks and all. So based on the availability of data, the particular system will be followed, and the feedback given may be implicit or explicit, and again based on the type, one particular paradigm will be followed. And another one is in which domain we are going to apply that RS system, recommender system, right? Suppose your application is location based application, then we have to go for the mobile based recommender system. So based on the domain where we are going to apply, we have to choose the appropriate paradigm, right? So mainly we have four major recommender system, sir.
Madam, someone asking doubt. Please wait, please. Yes, sir. Tell me, sir.
Hello.
Hello.
Yes, Vivek.
Sir, no, can you hear me?
Yeah, Vivek, sir. Please tell me.
Hello.
This is a simple like SDA services, online SDA services. That is using selective dissemination of information services. Similar like we providing online like based on the user queries, their matches. We providing these services to users. Similar like that only recommender system. Is it correct?
Vivek, sir. Sir.
Vivek, sir. Vivek sir, please.
Vivek sir.
Hello.
Yeah, please clearly, sir. Please clearly represent your please.
Okay, and at last I will represent. So just
Do one thing, sir. Kindly represent your words in chat box.
So you may type your query in chat window, sir.
You can proceed, madam.
Okay. So we have four major paradigm of recommender system. One is collaborative, then content-based, knowledge-based, and hybrid method. The last one is combination of all those things. We use hybrid approach. And apart from this paradigm, initially the recommender system that starts with the personalized recommender system. So in personalized recommender system, that particular user or the customer profile alone. Suppose X is one customer which is accessing a particular website for one product, and based on his or her profile alone, the recommendation system or this model, it will be modeled and it will search for those items which are all relevant to this particular user profile. Suppose the user is one academician, and he is usually searching for one particular domain, or he is usually searching for one particular book. Then based on his profile or history, those items will be listed. Even before he started the searching, it will provide list of items that will be interested to him, right? That is personalized recommendation system. Here no other information will be incorporated. Only that particular user profile past history will be used to make this recommendation list, to provide this recommendation. And here the type of logic followed is, sometimes the buyer or the customer or the user has thin profile, right? Say for example, every time he is searching for different product or different product, in the sense, one day he is searching for book and another day he is searching for some other product which is not relevant to that first item. He is searching for some automobile product, right? Then from his searching history, we cannot make a rich profile. We cannot make a rich profile, or we will not know what is the original interest for that particular user or the customer. So such buyer has a thin profile, or sometimes they may be a new user to that particular website. They may be a new user. For such users, what is the standard logic will be followed. Almost in all websites, once you enter into the website, the most trending items will be listed, or freshly arrived items, or recently reviewed items, or the discounted offered items with discount and all. So in almost in all websites, these items will be recommended in the first page itself. So if it is a new customer, then these things will be recommended to him. So for this recommendation, the technique or the model used may be a simple one. So on that particular day, whatever the trending item available or whatever the freshly arrived item is available, those things will be recommended. Then advanced logic, here the buyer or the customer has a rich profile with a sound history, right? So reason that is, he is buying some frequently he is buying some products related to automobiles, or frequently he is buying products related to books. So based on his behavior, or based on his interest, a rich profile will be created. And here we cannot use the simple logic. We cannot use our standard logic of recommendation system. Here we need one sophisticated recommendation algorithm, because we have lot and lot of information regarding that particular user. So it takes meticulous calculations on the history of data, and we need sophisticated recommendations, right? So actually here we need a recommendation engine provider. Say for example, a new customer visited that particular website, first time visitor. Then for the first time visitors, the recommendation engine usually show those things, most trending, latest deal, etc. And if he is a returning visitor, that is some old customer, then suppose recently he bought a road bike, then the recommender system is going to list or going to recommend some related products, right? So it on his arrival, suppose he is an old customer revisiting the website again, then based on his previous buying pattern, based on his previous purchase pattern, the recommendation system will provide some additional, maybe some accessories needed for bike, so that he may be interested to buy that particular product, right? Or some seasonal offers. So if he is a old customer and some seasonal offers are weekly deals or daily deals or rating based recommendation for his profile, some items are ranked, and based on the rating, that is the ranking, it will be listed. Say for example, the last year or the last season, that particular customer reviewed some of the items. He may reviewed some of the products, or he may bought he bought some products in the last or previous year. Then based on his history of data, some seasonal products will be listed. So that is what the personalized recommendation system will do. Say for example, recommended items that they previously viewed and left without buying. So first those items will be listed so that the user may again take the decision on those items now. Then the products they already purchased are added to the cart. Those items will be listed. Or some offer. So the some users here they will use other users purchase pattern. So if that particular product, say for example, if I am buying some bread, then some other related products will also be listed, right? So almost in all websites like Flipkart, Amazon, Walmart, they are following this technique only, personalized recommender system. Here the main thing is only that single user, that particular user profile alone will be used to take the decision, or it is used to provide the ranking for the items, and based on the ranking, top n items will be recommended to the user. And sometimes you can see some pop-up windows. Some pop-up windows will be side by side, some pop-up windows will be displayed. So here also they will increase the interest of the user, right? Suppose I am searching for one item X, and relevant to item X, they may recommend this may be interested to you. Like that, one small pop-up window will be displayed side by side. And here the thing is, the pop-up bouncing rate or the frequency should not irritate the customer. We should not, that is the pop-up window should not be displayed for every 5 seconds or for every 1 millisecond, etc. So after half an hour or 1 hour searching, if the pop-up window is shown, means he will not get irritated, right? So here the main thing is it should not irritate the customer, and the bouncing rate, the periodical, that is the time between two such pop-ups. That is some significant thing here. And it should not block the natural journey of the customer. He is trying to locate one particular item. He is trying to search for one particular item. but the pop-up window should not deviate his searching. It should not deviate from his normal flow. So that is the important thing here. Then apart from these pop-up windows and all, some websites they are following off-site recommendations. They will periodically send emails to recommend one particular product or to recommend the weekly deals or discount sales, etc. And recommendation through Facebook Messenger. So based on it is also off-site recommendation, and all these things are only based on the personal profile of the customer. So it comes under personalized recommender system, right? Dear participants, do you have any doubts or clarification?
Madam, actually, the question from Professor Vivek Kamba, yes, he actually he interact with us. Is recommended system similar like
Similar.
online, like STA selected
Yes,
dissemination of information?
recommender system is similar to STI, but in STI they may type the query. The user they may state what is his preference. But the recommender system, without getting any queries and all, it will use the past history or past behavior of that particular customer or past purchase pattern of that particular customer, and it will provide the recommendation. That is, without our knowledge, we are being tracked whatever the items we are purchasing and in which season we are purchasing that particular item and all. So those informations will be used, and based on that they will provide the recommendation.
Mr. Vivek sir, are you clear?
Sir, is it okay for you? Vivek sir?
Professor Vivek sir, Vivek Kapar, is you okay?
Do you have any queries?
Yeah, madam, actually,
Yes, sir.
yes, actually, you are actually totally it's online purchasing product, right?
Yes, sir.
Yeah, it is any recommended system for learning resources. I mean, library and everything.
Sir,
Any resources.
not able to follow what you are telling, sir. Your voice is breaking.
Yeah, please speak. Actually, you are actually in the recommended system. Is it for online product? Yes.
Yes, sir. Not only for the online products, for almost for all search engines. Wherever you are searching for some information, wherever you are trying to retrieve information.
Okay. Yeah, suppose we want some edition of the book. It is where you have to post it and where it is registered.
Yes, sir. Yes, sir.
Yes, I am. That's my question, madam.
Yes, sir. So almost whatever we are typing in the internet, whatever we are giving, whatever the query we are typing, or whatever the word we are typing, all those things will be tracked. All those things will be exploited, and a knowledge base will be. That is, they develop one knowledge base based on the behavior or based on the word we are typing. Everything is internally tracked. From that, they are developing a knowledge base, and that knowledge base only processed. In the recommender system, the data processing is done on that particular knowledge base, and again they are indexing the knowledge base in such a way that based on the interest or based on the domain, they are indexing the knowledge base. So here also they are following indexing. In the back side, we are following the indexing only. How to use IR system in an engineering college library. Okay. Suppose if you allow that particular user, suppose I am one user in a particular library, Normally, the library search machine will be, normally we will not provide any user information while searching in the library. Right, sir? While searching in the content page, we will not provide any our personal information. Maybe we will not provide our user ID, etc. Suppose if you permit the users to provide his roll number or user ID, then we may track, right? So normally in college libraries, the user, the search that particular website will be available. The user will just type what is the title they need or what is the author name they need. But if you allow the students and faculty to provide his roll number or his ID whenever he is searching for particular item, then we may build the knowledge base. Suppose I am providing every time when I am searching for one book in the library, I am providing my login ID. Then we may build a profile for that particular ID alone. Or we can build a profile for one particular student alone. So say for example, if he is a ECE student, then we can build a profile for all the ECE students. It will make our searching process easier. Suppose another ECE student login, provide his ID and he is searching for some book. Then we can recommend these are all the subjects you can, normally you will search for. Like that we can provide. But normally in library search system, the user will not give his ID or roll number. Right, sir? So if you get all those informations, the user ID or branch, which branch that particular student belongs to, then we can build the knowledge base. We can create the profile for every individual students or a cluster of students. We can build a profile, and that profile can be used by our recommendation system. Okay, sir?
Yes, okay, madam. Actually, another question from
So library,
Ravi.
in academic library, they might have the database book details and student information. They are maintained separately. Only when the student take one particular book, we get the user ID of that particular student. Right, sir? Only when that particular student is going to get a book from the library, we will get his roll number or ID. If he is simply searching for one particular item or one particular book, we will not get his personal information. We will not get his roll number or other IDs. Like, right, sir?
Yes, you are right. Yes.
Any other queries? Participants? Okay. Shall we continue with the session? Then the next recommender system is collaborative recommender system. Here, what we will do is, if the particular user bought some items, then we will see similar type of customers, their profile information, their purchase pattern or their behavior will also be incorporated in the recommendation engine. So in addition to that particular customer profile, similar type of customer profile is also being used, and based on that recommendation, sometimes in the website you will get the message, if you buy this, if you like this product, you will also like the other, they will show some other product. If you like this product, you will like this one also. Like that, they will provide recommendation. So that is known as collaborative recommendation system. Here, they are using the peer group data. Suppose this particular user is one ECE student profile, one ECE student, then we may study the community data, the peer group data, other ECE students data. this data is also being used to provide the recommendation, right? So tell me what's popular among my peers. So other students which are all having the similar kind of taste or the similar kind of domain they belongs to, right? So that is collaborative filtering recommendation system. Here what they will do is they generate the recommendation based on the current user's profile as well as other similar users rating profile. So normally used by almost all commercial e-commerce sites. And here, since we are going to use multiple users data, we need a sophisticated algorithms to model this recommender system. Almost in all commercial websites, they are using this collaborative filtering, right? Actually, they are using the wisdom of other crowd, other related crowd. But this idea is based on the assumption every user will provide the ratings. So always they are looking for the feedbacks or ratings once you purchase that particular item. So this collaborative filtering is mainly based on all users ratings. So they take the assumption every user will provide the ratings either implicitly or explicitly. And another assumption is the customer who buy that particular product will have similar kind of taste. So if he is buying this particular product in the past, then he will have similar kind of taste as like another peer customer, right? So these are all the approaches being used, mainly memory based and model based approach. So in one approach, we are concentrating on the user interest. And another approach, we are concentrating on item, the properties or characteristics of the item. But in both the cases, the nearest neighbor in the sense, the peer group, they must have the similar kind of taste. They must have the similar kind of thirst. So that is the meaning of the nearest neighbor here. So in simple CF approach, normally we use a matrix where we are maintaining every user's ratings. For every item, every user's rating is maintained in a simple matrix like format. Then we run the prediction algorithms to determine which, for one particular user, whether he will like that item or dislike. So for example, here this matrix consists of the rating given by all the users. So these users are now neighbor users. Neighbor in the sense they are having similar kind of taste. They are having similar kind of profile. Suppose Alice is one academician, then this group of users also belongs to the same domain or the same, they are having similar kind of interest. So we are maintaining all those users rating for every item. Now Alice, he is not yet rated this item 5. He is not yet used or buy this item 5. So here what they will do is they will see other users rating for this item. They will see other users rating for this item, and some user may be very similar to Alice. Some users may be from different, they have some dissimilar taste. So only those users who are all having similar taste, those users rating will be incorporated here to provide or to decide recommendation for this person. Okay. So such items are all selected and it will be listed whenever this person analyze start searching for some items. such kind of items, because already her interest is similar to this user 1, 2, 3, etc. If they are liking this item, means Alice will also like item 5. That is how that particular product is recommended to her, right? Can you follow this? So that is what collaborative filtering based recommender system. Along with the customer profile or user profile, it will consider peer group profile. For all having similar kind of taste, similar kind of searching pattern or purchase patterns, etc. Those data will also be used here to recommend one particular item to that particular customer. And now this user-based method is known as memory-based. And here that matrix will be used to do the prediction whether Alice will like item 5 or not. To make that decision or prediction, that matrix rating matrix will be used. But this approach cannot be used for real world commercial applications because we have millions of customers having similar kind of taste, right? Millions of customers, they might have the same behavior pattern, purchase behavior pattern or similar kind of taste. So we cannot use this approach for real-time applications. So what they will do is they will use model-based approach. So in model-based approach, those matrix data will be pre-processed. So the rating matrix data is pre-processed, and based on that a model is learned. Then afterwards, at runtime, only that learned model will be used to make decision or to make the prediction. Only that learned model, the learning is based on all users profile who are all similar to Alice, who are all having similar taste as like Alice. So once the model is learned, afterwards in runtime, we are going to make prediction using the learned model. So it is not a time consuming work. But periodically we have to update the model. That is the important thing here, right? Suppose that model is built around 2015 and the taste of the customers or the peer group may be changed after 2 or 3 years. So we have to periodically rebuild the model and retrain the model. That is the important thing here in model-based approach. And this method is known as item-based, also known as item-based approach. So in item-based approach, what they will do is, instead of considering other users' rating, and all, they will consider the other items similar to other items. So say for example, similarity between item 1 and 4. We are using Alice rating. Similar item 1 rating provided is 5 and item 4 it is given as 4. From that we can infer these two items are maybe relevant and the particular customer is interested on these two products, and now they will decide for item 5. If item 5 is similar to item 1, Alice may like this item, right? Or if item 5 is similar to item 4, he may like this item, and that value may be 80%, right? So based on this, they will recommend this item 5 to Alice, right? If your item 5 is related to item 1, then they will conclude if item 1 is liked by Alice and she may like item 5. That is how the prediction will be done, right? They will not use the user ratings, they use the product-wise ratings for making the decision. That is the second approach, item-based model. Then we move on to content-based recommender system. Participants, if you have any queries or doubts, you can interrupt me. If you have any queries or clarification, can ask. Otherwise, we continue with our session. Okay. So the next one, content-based recommender system. Here in collaborative filtering or collaborative recommender system, we depends upon, that is, the decision or the prediction will be based on other users ratings, other users feedback, or other users rating. We will not know what is the original content or what is the particular object or product is. So based on other users or other user ratings or feedback only, we make the prediction. But in content-based recommender system, in addition to other users rating, we will see the properties of the product. Suppose he liked this product, then here we consider the characteristics or properties of the product, and those things also used in the recommendation process. If he likes this product and there is another product which is similar to this, it is similar to this one, maybe color or some other properties and all, so it will be recommended to him. Here the that is the product properties, item properties or other characteristics also